because the 7-week class I started was on a Friday, which was on the 22nd of May, right? The 2nd of May. That was supposed to be your 7-week, if you recall. And then you go off for Hari Raya Idul Fitri for 1 day, and then I don't know. So did we have a class on the 2nd of June or not? Do you remember? Anyone? So if that, can someone respond to me? Hello? No one can respond? I'm confused, guys. Mira says, hello, I'm asking a question. My question was, did I have a class on the 2nd of June? Okay.
Tak ada, sir.
Who are you?
Amy.
Says no. So, okay, in that case, then I better correct it.
Sir buat kelas 5 hari bulan 6, hari Jumaat.
Kita buat kelas berapa hari bulan?
5.
5 hari bulan?
6.
6.
5 hari bulan 6. 5 Jun.
Oh, that 5 hari bulan 6 was the 8th week then?
Yes.
Yes? Okay. When did I have your 7-week class then? 7-week class. The 22nd of May. Did we not do a class then?
Sekejap, nak check dalam group.
Who am I talking to?
Amy.
Amy.
Okay.
Ayah.
22nd May pun ada kelas.
Ha?
22nd May pun saya buat kelas.
Saya buat kelas kan? Okay, so that was your 7th week.
tu week 7.
Okay.
So buat kelas untuk week 7 kan. Lepas tu kita cuti raya seminggu. Lepas daripada tu 5th of June saya buat kelas untuk week 8. Macam tu.
Oh, okay. Then I missed out. Okay, now good. So I have week 8 here. Now I have week 9 here. I have week 10 here. So today week 11.
Yes.
So okay, let me correct this now. Week 8, I did foundation engineering class 2 to 5 p.m. Okay, then up to week 8, I have another one which is 9 of June. Right?
Betul.
9 of June. 9 of June is week 9. Yeah?
Yeah.
So 16 is week 10. So now week 11.
Yes.
Oh. Okay, fine. So I have to finish settlement today. Now I have to continue. I have to continue next week. You know, but I want to. I have basically 4 more weeks, right? No, 3 more weeks. 11, 12, 13. No. How many more weeks do I have? I'm confused, guys. Today is week 11, 12, 13, 14. So I have 4 weeks from today, right? Yes, Amy says yes. So I have 3 weeks. So I basically start 3 weeks for piles, and I thought that, before that I have to finish settlement. In fact, I took a longer time with you in respect with settlement because on the 8th, on the 5th of June, I was actually already started with settlement, right? So I am taking longer with settlement with you. Okay, all right. Now I have 45. I cannot wait anymore, so I'll call at some point in time. I'll have to call the attendance. Yeah? Or shall I do it now? What do you think? Come on, guys. Respond to me. Say something. Shall we get rid of all this business? Erin says, okay, sir. All right. Siapa yang tak ada tu absent lah. Nasib lah kan. We cannot be doing this, right? We have to come to class. All right. Amy says start. So I have rotated this, but now I'm just going to get this. All right. Now. All right. And Petra says start. But I need to call the attendance now, right? So siapa yang tak datang tu, too bad lah. All right. You know. Okay. Is that okay, guys? I'm going to call for your name and then you have to say present. All right? Okay. I'll start with the name. Muhammad Zarif. Present or absent? Go, sir. I don't know how. Shasha Zukrina absent. Yang absent ni apa Shasha Zukrina? Yang Ain Suada ni. Sir, 56 include you. Oh, okay, fine. Thank you, Iskandar. Good. Otherwise, it would be like, sampai pukul 5 petang kita macam ni. Hey, ya Allah. Alright, let's go, guys. Let's do this. I'm good. Yeah. Let's go. Alright, if I can finish today or if I decide let's not finish today, we'll just continue with PALS. But remember that we have to finish it by the 14th week if you want it that way. Otherwise, then, too bad for you, right? If you don't want it. So when I say that, I mean that you have to be prepared to sacrifice your time. You may have to, take more than 5 o'clock, right? Shakira, you are okay, right, with your internet now? She's not listening to me, or your internet is not good. She said she's back now. 50-50. Are you still in Kampung or are you back in Melaka? Melaka already? Alamak. I thought everything okay with internet. Yeah. But okay, I'm starting with, as I told Shakila, because I was panicking because we are on the 11th week, so I'm panicking, and then I'm thinking not panicking because I was thinking that if it is the 11th week, I have to finish settlement, right? But given the circumstances, already taken 1 hour, almost 1 hour with respect to just getting the roll call, all right? Present, absent, done. So we'll do at least what we can, and then I think we can still adjust the pile foundation. By next week, I want to start pile foundation, but I think we can adjust with the pile foundations and settlement. So I'll probably give the homework by next week as well. Yeah, Iskandar, you just realized 1 hour just gone for the stupid thing calling your attendance. Now, settlement of structures on sandy soil. Okay, we finished with clay soil. We are now on sandy soil. Okay, now the thing about sandy soil, are you on page 14 now? Yes or no? Might I suggest we collect the attendance by Google Form next time? Akmal, yeah, it's a good idea, but how do I? Okay, I'm taking 5 minutes, right? If we take to Google Form, how would you will what? Do the ticking and then you will mail me, or I have to go and access the thing? I can administer the Google Form. Okay, Akmal, when do you want to do it? Before, after, middle? And send a spreadsheet to you. Send a spreadsheet meaning on Lotus. Or I mean on Excel. Before and after. Before and after, yes, Excel. We'll do, I don't want to sound like a prefect or something like that. I would like to assume that everybody come to class, but given the circumstances, I tell you what, Akmal, as we go along, right? You don't have to give me the spreadsheet. All I need to know is who is absent, right? Who is absent on that particular day. So because I need to have it fill up in ESMP anyway, right? And I'll give it to the officer because right now I'm going to use a Latin word meaning persona non grata. What that means is that I'm no longer in existence at UPM. So I have to give it to the officer anyway to fill it up for me, right? Unless I can have access to the email. But I had tried to get that sorted out last week, so I don't know what's going to happen yet because things are going crazy in respect to all the SOP and the procedures at UPM now. 1 minute they say I don't need a letter, the next minute they say I need to find a letter. Everything is like they don't know what they're doing anyway. Okay, so Akmal, that sounds good. So at the end of the lecture, perhaps you can just send me who is absent, and then I'll just stick it on my attendance list. So that would be enough, I think. Right? So as long as I see by 5 o'clock, you can just do it all, and then I mean not 5 o'clock, 5:15, and then you can send an email to me, right? And then I think on who is absent, then it will be done, right? How's that? Does that sound okay? I wouldn't know who is absent, only the ones who are present, the ones that fill the Google forms. Oh yeah, right. Because you don't have the attendance list, huh? Okay, then you give me on who is present, right? Then I can just tick on who is absent, right? Okay, it's still the same job. Okay, fine. All right. Okay, now let's just move on. Page 14. Okay. All right. You are on page 14, right? Okay. So I'm done with clay. All right. I'm done with clay, and basically I talked to you about the different methods of dealing with settlement in clay. All right. And if you recall, we started off with the odometer test, and then we said to ourselves that if we look at make comparison, in relation to observed results, actual data result, we said we're not too happy about it. So we said that let's just have a look at what Skempton and Barham, not Skempton-Barham method. Is it Skempton-Barham method that you call it? I better not use other words. Yeah, you call it Skempton-Barham, the Skempton-Barham method. All right, Skempton-Barham then basically use the idea of the odometer but make corrections to the odometer. So you have the A and the nu, all right, coefficient being introduced to you, and I explain what they are to you, all in relation to the triaxial test. And then we made that comparison. So the Skempton-Barham method and the odometer method with observed result, and we still see that it is an improvement with respect to the odometer test, but not as great as an improvement in relation to getting the result very near to the observed values. And then we ask ourselves, why is that the case? Well, we didn't ask ourselves, but Skempton and Barham did ask the question, and he said that, he alluded to us to the idea of over-consolidated clay and normally consolidated clay. And the idea of this overly consolidated, normally consolidated clay, I explained to you that, it's just the stress history, basically how an element of soil has been compressed with time. So with that in mind, then we then say to ourselves, okay, in order to find this settlement, all right, we have to know what the influence of stress history, and for an element of soil to know about their stress history, we use this stress path. All right, the stress path, which is a locus of the peak of the Morse circle, and we use on the x-axis and the y-axis, the vertical axis and the horizontal axis, the denominator P's and Q's. Right, so one has effective value, the other doesn't. All right, so the P's and Q's, and I showed to you all of that. So then, if we know about the stress history, we can realize that, for the one of the stress history in the field, not the one-dimensional test or the odometer test. You see, those are the words that you use for the one-dimensional test, odometer test, conventional test. They are the same thing, right? So you notice that the stress path is different, and that you have for the field test, you have the immediate settlement being accorded by the stress history, all right, the stress path of the field test as opposed to the odometer test. So if you know that, then you say to yourself, we then now have to estimate the stress history for a sample of soil that we take from the field, and then we would find the settlement. So there you are at that point in time. I said to you that I'm done with clay. All right, I'm done with clay. You basically have all the ideas about clay, all right? And then for clay, anyway, if you're doing bearing capacity and you're doing settlement in bearing capacity, you have to do undrain and drain. And then in the stress part, in the settlement, okay, you draw the stress part, all right, and you see that dissipation of pore pressures and whatnot, and then the initial pore water pressure then reaches the final pore water pressure. That was what we did last week, and then finally is being dissipated, all right, and you were doing it in the undrained condition, all right, the consolidation pressure. Okay, moving on with sand. With sand, then we are not dealing with this undrained drain condition. We are dealing with mostly drain condition, because the moment you put water in sand, it just goes away. There is no build up of this pore water pressure. Why? Because in soil mechanics 1, you learn that the pores of sand is much bigger than the pores of clay. All right, and in fact, if you can remember in chapter 2 of the permeability test of the topic on permeability, I'm opening up the chapter 2 again, the table. Why am I opening this up? Well, because some of you didn't do that soil mechanics 1, right? So if I'm on page 39, all right, there is this table. This table here, which shows to you the permeability of clay and sand. And you'll find that permeability of sand is much higher in comparison to sand, right? We're talking not just like 10 times. If I'm just taking one clay here, right? Unfissured clay is 10 to the power minus 8 meters per second, all right? And if I take just fine sand, all right, it's 10 to the power minus 6, 10 to the power minus 6, and 10 to the power minus 8. That's like how many times? 10 to the power minus 6 and 8 is like 2. I mean, 10 squared time, right? That's 100 times. But if I'm taking like clean sand, it's 10 to the power minus 2 as opposed to 10 to the power minus 8. That would be 10 to the power of 6 times, okay? Much faster. So if you are not familiar with what I'm saying, you can look at this chapter 2, all right? And it's on page 39, permeability, to give you an idea what I'm saying. Why there is no build-up of pore water pressure in sand. Because I said to you a few minutes ago, the pores in sand are much bigger than the pores in clay. All right. So, the one that I took just now is even like, 100 times faster than the clay. All right. And most of the time you see that in your example is clean sand. So you're talking about 10 to the power minus 10 to the power of 6 times much faster, the flow of water in sand as opposed to clay. Now, that's one thing about sand that you should know, right? As opposed to clay. That before you come to this class, you should already know that. The other thing, if you recall from the site investigation class, right? Sand, or even before, sand doesn't have this. Well, if we're generally speaking, we are talking about it is cohesionless, all right? Or it has very little cohesion as opposed to clay. So in order to in site investigation class, I told you that it's very difficult to get sand, to sample sand. All right, you can't take it out and get it like clay. If you recall the picture of the clay, when we had that slideshow, right? At the end of that slideshow was a clay which was covered with wax, right? You can't actually do that with sand. Okay, so sand is like your rice at home right now. If you are at home right now, you try to get that rice, right, without any boiling done. You see, it'll just go away. But clay, you can actually sample it, right? You can make it into a cylinder. That gives you the idea of cohesion. So it's difficult to sample the sand and bring it to the lab. By that, I mean undisturbed sample, not disturbed sample, right? Disturbed sample is okay, because you can't be bothered about it. You just pick up the clay or the sand, right? But if you want to test in odometer test, in triaxial test, then you need an undisturbed sample. Clay, you can basically do that, and you hope you reduce the disturbance. But sand, you can't. So generally speaking, when we find sand in the field, what we tend to do is we tend to do our test on site. Okay, if it is a disturbed test that we need. So this is why, all right, in site investigation, we had two tests being introduced to us that is more related to sand, which is the SPT and the CPT, the standard penetration test and the cone penetration test. We also have all the other tests, the plate bearing test, right? But for today, I'm talking about the SPT and the cone penetration. The other two and much more of the other field tests for sand or clay, right? We can talk a bit later. Now, today, SPT, all right? So again, in SPT, what was it that we are looking for? It is the standard penetration resistance. The symbol we used was N, all right? And if we recall this SPT, it is, we have a split spoon sampler, all right? It's driven by AMR of 63.5 kilogram, freely falling, 763 millimeter. This 63.5 is the Australian standard. It's not the British standard. For the British standard, I know what it is in my head, but I'm not telling you. Why? Because I want you to go and read it yourself. All right. Some people are not in the habit of reading. When they are not in the habit of reading, they get into trouble. Mark my words. All right. So read it to make the distinction, the difference between the Australian standard and the British standard. Why do I want you to make the distinction? Because whenever you pick up a standard, right, and you do a test, right, and then you want to use the result, you suddenly realize that, this result is a function of some procedures, which is not the same as this procedure. So it is not easily interchangeable. All right. Or if you want to do you want to use this other chart instead, all right, then you have to do the necessary correction. So as long as you are aware of this, then you are a little bit more careful. This is why I ask you to do certain things. Okay. All right. So again, you just use your split spoon sampler and you go bang, 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 bang. And for the first 150 millimeter, the next 150 millimeter, and the third 150 millimeter. You make the drive for the penetrometer at a certain depth. All right. 450 millimeter, but the first 150 millimeter, you don't count it. Right. I mean, not that you don't count it. You count it, but you don't use it in the definition of the N value. The N value is the last 300 millimeter. Okay. The first 150 millimeter is just to sit the penetrometer, because you will recall that the penetrometer is going into a hole, a borehole which you drill. All right. And then you arrive at that depth where at the borehole, and then you go bang, bang, bang. So the first 150 millimeter is just to take care of any disturbance if there is any, when you did the drilling. All right. Then the next 150 millimeter, you count it and you consider it as part of an N, and the other one another N. So 3, if you get the first 3, the first 150 millimeter, 1, 2, 3, bang, okay, you get 3. Then the second 150 millimeter is another 3, so you get another 3. So the 300 millimeter total up to 6 bang, right? 6 bang equal to N. The first 150 millimeter, maybe it is 1 and maybe it's 2. So you don't bother with the first 150 millimeter anyway. All right, so that's what N is. The number of blows required to drive sampler 300 millimeter after initial 150 millimeter. The total drive is 450 millimeter. Now, you will look at the overlay. Overlay is not two pages overlay. Here, this page on page 15 or whatever it is. 2-page overlay. All right. Now I've seen that chart. Okay, the chart says figure 1410, Peck, Hansen, and Thornburn. It proportions the footing between N, bearing pressure, limiting maximum settlement to 25 millimeter. All right. Design chart for proportioning shallow footing on sand. What that means. All right. If I just take one of the charts, C here, DOB is equal to 0.25. D is the depth, B is the breadth. Okay. You notice that it is linear up to a point and then it becomes horizontal. All right. Then the SPT values are that. Okay. Now, N is the standard penetration resistance. N is an indicator of the strength of the soil. Right? Because you are banging it. Bang, bang, bang. If you recall your SI, that's why it is a strength. All right. So, but we are talking about settlement here. So, what is this chart trying to say to you when they say to you proportioning the shallow footing? All right. They are saying in sand. Okay, they are saying to you, I am going to limit the settlement to 25 millimeter. I'm not going to calculate the load, and then I'm going to stress the material soil, and then find the settlement, and then see whether whether the soil can take this settlement. All right, with whatever load I'm giving. They're not saying that to you. They say I'm going to limit the settlement 25 millimeter, and then I'm going to find the footing where the settlement is going to be 25 millimeter maximum. Now you get the picture. Limit my settlement 25 millimeter. 25 millimeter is about that much, 1 inch. You know, shallow footing. I have a footing at some depth D. I have footing some breadth B. It's going to fall by 1 millimeter, whether I like it or not. All right. So you're going to fall by maximum 25 millimeter. What size of footing, what size of depth, what size of load. Okay. So this is what they are saying to you. When they say you use this figure 14.10, all right. So figure 14.10, all right. So now I have two things when I said to you, right? All we're going to do in this class, I said, was investigation. When I'm going to do shallow footing, I'm going to do deep foundation. And in each of this shallow footing, I have bearing capacity and I have settlement. I have deep foundation, I have bearing capacity and settlement. If I can satisfy bearing capacity, not enough. I need to satisfy the settlement. Right? You now know how to calculate bearing capacity, all the formulas, and then the bearing capacity is a function of C and P. All right, the shear strength parameter. Now we are dealing with the settlement aspect of shallow footing. So now they are saying to you, okay, if they have an SPT value which has a certain strength, I'm just going to limit the settlement then. All right, I'm going to limit the settlement to 25 millimeter, then I can find the size of the footing, and then I can just put it at some depth. If it doesn't satisfy that, I cannot use it. Okay? Am I going fast, guys? Or are you following me? But anyway, if you don't follow me, there is an example. Soon we'll do that. Right, guys? Or are you half asleep now? Say something to me. It's gonna say yes, sir. Yes, sir, meaning what? All right. Okay. Now, that same figure, okay, is found on page 320 on your Craig book. All right. Why am I showing all these charts and things? Because when I give homework, sometimes I feel that you don't actually learn anything from the book. All right. You just copy or you just think you know or whatever. All right. And when you sit in the exam and I gave you some of these charts from Craig, you said this, your face basically tells me that I've never seen this chart. You see? So this is the reason why I'm showing this to you. Okay? It's the same thing. All right? Only that is drawn a little bit different. Now, I alluded to you about the fact that this is horizontal. Okay? This is horizontal because we said that the settlement is going to be limited to 25 millimeters. So, whatever strength, whatever load I'm going to put, all right, if it reaches a certain value, all right, beyond the 25 millimeter, you know that stress and strain, all right? You know that if I increase the stress, I should have an increase in strain. Well, here it doesn't occur anymore. Why? Because I said that beyond 25 millimeter, I don't care anymore what you put, but I want it to be 25 millimeters. So in other words, I'm saying to you, don't put it there. So that's why this is horizontal. But here, less than 25 millimeter, the stresses are linearly increasing. Well, figure 14.2 is linearly increasing. This one is a bit showing linearly increasing. Okay? That's the other thing you should make the distinction. Okay. But if you use this chart, they said to you that the SPT that you get from the site investigation, all right, you have to correct it. You have to correct for two things, but the presence of the water table and also this thing called overburden pressure. Now, this overburden pressure is to relate to you about the stress history. When you compress it and you keep compressing it, it becomes stronger with time. That, in clay or in sand is the same story. So that's why they say you have to correct it. So this is figure 14.12, and it is for the correction of the overburden pressure. Okay, overburden pressure is this pressure that is above the element. All right, and that correction factor is just called C sub n. So you just calculate your overburden pressure. If it's at some depth Z, you just know the unit weight. You take that unit weight, you multiply by the depth, and then, hey, you go through that chart and you get that correction factor. Correct. So do the correction for the D overburden, and you have it in your head. You said to yourself, well, since in clay, stress history has an impact on the element of soil. It's the same as in sand. If I am like, I have Amy on top of me, and then I have Mira on top of me, and I have Akimi, and I have Arman, and I have so many other people on top of me, as compared to if I just have only Amy on top of me, then obviously I am more stressed, isn't it? I am more stressed, and I am obviously, have more strength. See? Then if I just have one person on top of me, right? So that's why where and how the soil was compressed previously has a relationship to to the correction factor, right? Because when you have the hole, you drill the hole, right? You drill the hole and then you bang it in. You're already removing some of this soil away, right? But that soil in the past has been, the element of soil has been stressed. You see, that's the difference between over-consolidation and non-consolidation when I spoke to you about it in clay. So it's the same story as in sand. Anyway, you got this idea in your head, you see, that I was once compressed, all right, for a long time. I had weight over me. So obviously my strength has been increasing over that time. Okay. So, and then when I remove a bit of the soil, all right, in the drilling hole, and then I am trying to find the strength of the soil by the SPT, then obviously I have to do some correction. Now, the other correction you have to do is because of the water, right? I said to you, after that I have to come back to this, something else about this overburden pressure as well. Well, I'm talking about the water, right? Because when you have water, you know, your pores are filled with water. So the strength is not the same when you are not filled with water. It's like when you're sitting on clay, right? In the wet season, you probably sink, right? And then when it's dry, there is no water in the pores, and then it's not the rainy season. You know, if you try to even make a hole in the ground with your leg, so to speak, right? You stamp on it, and you find that your leg is you have a painful leg. In other words, what I'm trying to say. Okay, so that's the idea. All right. So the overburden pressure, I showed you to you earlier this chart, right? Sometimes I'm a bad boy. I don't give you this chart. Then you're like, you didn't give me the chart, so what am I supposed to do? But I did give you a formula. All right. So you don't have the formula, then you get into trouble as well. You see? Sometimes that's the way the question is being made. No chart, you know, no nothing, right? So it depends on you. So for the correction of that overburden pressure, that's the value C sub n is equal to 0.77 log of 2 over P prime. That P prime is the overburden pressure. I told you just now how to calculate it, right? The effective value. But the P prime, in order to apply the overburden pressure, it has to be more than 25 kilopascal. Okay. The units of the P prime in that formula, C sub n equal to 0.77 log 2 divided by P prime, it has to be in megapascal. If you calculate it in kilopascal, change it into megapascal, stick into the equation, get you C sub n. Clear? Yes or no, guys? Okay, inshallah, clear. Fazli says good. All right, Ira says yes. Wow, Muaz says yes. Good. All right, then we have the water table. If that water table is less than the depth D plus B, D again is the depth D, B is the breadth B. All right, then we need to apply the correction factor C sub W on the allowable load. Okay. All right, on the allowable load. Now, the C sub W is given by the equation 0.5 plus 0.5 D sub W over D plus P. D sub W is the depth to the water table, all right? And then D is the depth to the lower end of footing, i.e. the footing level. So you have that, all right? Can you see this? Oh, I don't have to go and look at you. Yeah, you have the depth D to the lower footing. Okay. B is the width of footing. You can probably put it in there. I can't be bothered to do certain things if you know. Yeah. Yeah, now I've drawn the B in there. There, can you see it? Can you see the B? I've just drawn in the B. Now I've drawn the D. Okay. Shall we put a water table somewhere and put the DW? All right, just for your sake. Now I have the D sub W there. And I have the water table drawn in there. All right, so I put the D sub W. Okay, can you repeat on how to calculate overburden pressure? And you're asleep half the breathing time. Overburden pressure is the same as the vertical pressure. How do you calculate the vertical pressure? Gamma multiplied by the unit weight multiplied by the depth. Yes? Yeah, times by the depth. That's what it is. It's the same thing. Okay? Then, of course, if it is effective value, then If it is effective value, then you have prime values. Okay, you minus the gamma W, right? If it is a total value, then you don't have to, right? If it is total, then you don't bother lah. But if it says effective, then you have to bother lah. Okay. All right. Now we go for the example. All right. So you remember all the SPT. This is the reason why at that point in time in site investigation, we only learn about the procedures and what it is, and then we had some charts which relate the idea of strength, right, to the SPTN. If you have forgotten, you might want to have a look at it again. So now we realize what they are for. Okay, we are applying the SPTN value, right? All those procedures we do to settlement. Okay, so let's look at the example. The first example that I have is on figure 14.3 or 14.30 of the note. I'm not going to go through that. You can read that yourself. All right? Okay, 14.30. This is trying to relate the site investigation and also to today's lecture. All right? And it's more of a review in a sense to you. Okay, so you have the result of the standard penetration test, and then it is in a medium cost set. You have the hole, there are 4 holes there. Then the values, however, have been corrected for the N values. All right, these are not the raw values. Then the depth are given there. Then it is also shown that water table is at some point. All right. And then you are supposed to make a comment upon the proposal to place a 3 meter by 4 meter footing at a depth of 2 meters to carry a load of 1 meganewton if the settlement of the footing is to be limited to 25 millimeters. So that basically tells you that I'm going to use figure 1410. All right. That I don't need to calculate the settlement. I'm given the SPT. So figure 1410 is the relationship. All right. Then that's all the comments are there, and then hopefully you get the idea behind the testing and the calculation. It's just a design. Now I want to do that example on page 8.5, page 324 on Craig. Why do I want to do that example, not spend too much time on figure 14? Because figure 14.30 and that page 14.30 is what I've been explaining for the last half an hour at least, right? What this idea of SPT and how we use it. So I assume you will take the necessary time to do it. Now in this page, on page 324 of Craig. All right, it's example 8.5. Do you have it? Yes or no? Nadia, yes. Fazli. Okay. A footing 3 meters square is to be located at a depth of 1.5 meter in a sand deposit. All right. Why don't you draw this? It's a footing 3 meters square. So it is 3 by 3 meters. And the depth is 1.5 meter in the sand. So you put B times B equal 3 times 3. Depth of 1.5 meter. I've already shown to you this drawing just now, so you can draw it yourself. Right? This you can draw it just now. In the sand. Deposit the water table being 3.5 meter below the surface. You can now put D sub W is equal to 3.5 meter. And then values of standard penetration resistance will determine as detailed in table 8.5. Table 8.5 is on the next page. All right. And then you need to determine the allowable bearing capacity using the various design method. I'm not going to do the various design method. I'm going to stop up to the Peck, Hansen, and Thornburn method. After that, I'm not going to do it anymore. Okay. All right. And of course, they say that some of those corrections are on the names, but I couldn't be bothered to say those names here. Okay, are we okay with the drawing? That's not difficult, right? 1.5 meter to the lower end. And then only that the water table you notice here is below the depth of the footing. Yes or no? Razim says yes, no big deal. Okay. All right. Amy pun cakap yes. All right. You know, if you have the picture now, right? You should now put beside the your footing, okay, the depth 0.75, 1.5, 2.3, 3.7, 4.45, and 5.20. Just beside your footing. Here is my big picture. Okay, this is my big picture. All right, just put the depth 0.75, 1.55, 230. It's okay if you don't get the scale right. You can do it after this. All right, just get it right. And then I want to put at that on those scale the SPTN. Can you do that? Just have a rough idea. Then after this, you can like spend time to do it on yourself. I have to try to get this paper somewhere. Okay, there I got this paper. So if I were to draw it, I probably have something like that. Let's just draw it, right? So I have 3 times 3 meters. And just to remind myself, this is P times B. Then this is what? B, 1.5 meter. Then I have up to some point here, water table, 3.5 meter. Now I'm going to draw it, like I said, not to scale really, but you know, as long as I get the idea in 0.75 meter, then 1.55, 1.55 probably is 1.5 here. All right, then 2.30. 2.30 is probably somewhere here. Okay, SPT here is 8. ASP here is 1.557. This is N, this is depth. Okay. And 2.30 is 9. All right. Yeah. Can you like see this? Say something if you can't see it. Yes. Hello. Amy says yes, Fadi says yes. You get a rough idea. You need to do this, right? Okay, continue doing this. You can draw after this to scale, but you get a rough idea of what I'm saying, right? Because the words I'm going to use soon after this is going to be in relation to this picture. Okay, so if I look at this picture, right? Well, I'm not going to look at this picture now. I mean, I just have the picture in front of me, and then I can like go through this example. So it says the next paragraph. Kazagi and Pat recommended that N values, which is the SPT values, right, should be determined between foundation level and a depth of approximately B below the foundation. Okay, between foundation level and a depth of approximately B below the foundation level. Okay, in this case, between depths of 1.5 meter and 4.5 meter. The values at depth of 0.75 and 5.20 are therefore superfluous. You get that or not? Now that's why this picture is important. Okay, because basically it says disregard the SPT All right. Between foundation level and a depth of approximately B below the foundation. Yes or no? So take the values of N, yeah, between foundation level and a depth of approximately B below the foundation. So this is what is meant by that statement. Yes, D plus B, between D and D plus B. Now you either have to say yes to me or no to me. Hello? Guys, are you awake? Mira says yes. Yeah, between the footing level and B below the footing. Okay, Abby says yes. All right. Now the question is why? You will remember this picture that I draw now. All right, this is B. Remember this picture? This one, to do with the general shear failure. Yes, I have a triangle and then I have the active zone and then I have the radial shear zone. The general shear failure, okay, Nadia says yes, Amy says yes. Now, this, it is not exactly B here, all right? This is not exactly B, but it is roughly B, okay? So this is the idea of bearing capacity. Now, this is the idea of bearing capacity trying to relate to settlement. We said to ourselves the strength of the soil in this figure 1410, the strength of the soil, this SPT is going to be relating to the settlement. Okay, so that D plus B here between footing and between this B depth goes back to this general shear failure. All right, because you might be asking, what the heck do I have to take between D and D plus B? Well, it has to do with that general shear failure. And that general shear failure is the bearing capacity. But now I'm saying to myself, I'm going to limit settlement 25 millimeter, which has relation to that bearing capacity, the strength. Okay, all right. Now, so that's why it says the the values at depth of 0.75 and 5.2 are therefore superfluous. Forget about the answers, forget about the SPT above that. So this 0.75, even though you took the trouble to do the SPT test, it has nothing to do with this using figure 14.10. And the same with figure with that 5.20. That 5.20 is beyond the D plus B. Okay? So guys, it's not enough that you just take a table and then put the N and SPT and then just add up, find the average. This is not a class in mathematics. All right? This is a class in foundation engineering. And it has relation to your understanding. So you cannot forget this bearing capacity. Otherwise, you memorize this. When you memorize this and you follow this, right, for no apparent reason, this is how you get your mistake done. All right, and the mistake and more mistake and more mistake, this is how you fail the class. Although I make it very difficult to fail the class. You see? So this is why I keep saying to you, you have to know what you are doing. All right? Okay. Now, so now it says N values are corrected using equation 8.14. That equation 8.14 correct it for the overburden value. All right. So you have now the sigma prime B. Then you calculate that for the first one, 8, because it's superfluous, you're not going to use for the, has nothing to do with this using figure 14.20. It has nothing to do with you putting load. Yeah, putting load and then having a settlement down there, right? Which is occurring between this general shear failure mode of failure, right? So that's why don't bother to calculate sigma B. You can calculate, but don't use it. All right? And no relationship. For every stress, there is a strain. All right? So, but if you stress it above, if you stress it above the footing, then you won't have the strain. Why are you calculating the strain? Okay, fine, good. So I calculate sigma prime B. Values of effective overburden pressure are calculated using gamma equal to 17 above the water table and gamma prime equal to 10 kilonewton per meter cube below the water table. I've said this before to you. If for some reason they don't give you, all right, if they don't give you the unit weight above and below the water table, yeah, then you just take whatever values they give you, because that is the value of the unit weight. It doesn't make a difference. They're saying to you whether you are above or below the water table. All right. Then you just minus your gamma W. Your gamma W, your unit weight, you always know it as 9.8 kilonewton per meter cube. You always get it. All right. Why am I saying all of this? Every year I say it. But by the time you get into the exam, you say, you don't give me this, you don't give me that. How am I supposed to calculate? Then I'm saying to you, you're half asleep. All right? And you have forgotten everything I told you. So write it down. All right? Okay. Now, in this case, they give it to you. Right? Why don't they give it to you in the question? Because, like I've said to you, the difference above the water table and below the water table, there isn't much of a difference. Sometimes. Yeah. So that's why they just give you one unit weight, which is the total unit weight. All right. And to you, 1 meter may be big, but to the soil, 1 meter is not big, nothing to them. Right. So and plus the difference in the pores of the water table right up to the surface, right? It's not much of a difference. Okay. So this I have told you in site investigation. I'm telling you again that some of these things occur. So don't get your, in English we say don't get your knickers around the twist. Basically, I don't know how to explain that in simpler language. In other words, don't get yourself entangled over unnecessary situation. Okay. All right. Now, and the corresponding values of C sub n determined from figure 8.8. Okay. If you are not given the figure 8.8, you might want to use the formula. All right. Use the formula. So perhaps you are doing this example again. Do the formula. All right, and compare the C sub n values that you obtain from the formula and as opposed to the chart. So then you can calculate the average corrected values n sub 1. N sub 1 is just you multiply C sub n by sigma v, right? Then you get the corrected values and then you take the average, all right? And you get it to be 16. Now, the average is 16. Can it be 16.1? Hello? Can it be 16.1? Yes or no? Come on, guys. I don't have all day. Ein Pitra says not sure. The problem, Ein, what is n? This is why you cannot memorize things and just leave it at that. What is n? Anis Nadia Jafar says, cannot, sir. Okay, Rohit Matutayba says, number of load. So, n is number of load, Najmi says. So, now Ein, no one else. Nadia says number of loads. Okay, Ein, can I have 0.1 number of load? Now Ein is thinking. The AB is answering for Ein. No, sir. See? Why not? Why can't I have 0.1 blow? Ha ha ha, Fazli says. Amy says impossible now. Okay. Ha ha. Right, Ein? So, kan, how to blow 0.1? Pandai pun habis. Right? So, yeah, all right. That's why I'm saying I am trying to impress on you people. If you just memorize and do not know what the thing is all about, you will do funny things. Okay? So, this is why I'm trying to relate to you all these things. All right? So, because you do everything, you say 16.1, and I'm like looking, yeah, right. 16.1. Right? Then you accumulate all this mistake. All right? Again, reminding you, we are not doing a mathematics class. We are doing a foundation engineering class. We are employing all the knowledge from soil mechanics 1 and soil mechanics 2 and all those things that we learned thus far, all right, to apply to design a footing. All right. So moving on. So now after that, it says it's 16. Then referring to figure 810. For B equal to 3 meters and N equals to 16, the provisional value of allowable bearing capacity is 165. So now you get the bearing capacity. Okay, 165 kilopascal. At this point, I'm going to ask Ein, and Petra is going to answer me. All right. Let me see the picture again first before that. Figure 810, right? Let me see figure 810. Everybody should look at that, right? B equal 3 meter, N equals 16. B equal 3 meter, N equals to 16. Ini dia. Okay. It's halfway through, right? 3 meter, N equal to 16. Here. Okay. All right. So if I were to like ask you, what's the maximum settlement for that B equal to 3 meter, N equals to, for B equals to 3 meter? Maximum settlement for any footing. I should say that. Ein. Maximum settlement. Ya Allah. Come on. Or anyone else. Okay. Arman says 25 millimeter. So if I were to like, you know, if I were to just project that along the line B equal to 3 meter, N equal to 16, right? N equals to 16 is somewhere here in between 10 and 20, right? In this chart that they have, it is not a straight line, but in my chart, there is a straight line with D over B and all of that. So if I were to put it like that, right? B equals to 3 meters somewhere here, it goes up and then it becomes horizontal. This horizontal is the 25 millimeter. So this is going to be the maximum settlement where if I were to have a different B, 25 millimeters. So I can have, you know, somewhere here, say, all right, and anywhere between 0 and 1, yeah, 0 and 1 B. Yeah. Okay, guys. Because you are proportioning your footing. Yeah, 25 millimeter, this settlement will have this size of footing. If I have 3 meters, all right, I will have not 25 millimeter, probably about what, halfway through. So I probably have about 12.5 millimeter, right? Rough estimate. Okay. By the way, 25 millimeter is 1 inch. I don't know whether you know that. Anyway, if you don't get that, then it's okay. But, you know, I'm trying to give you all those things behind the story. Yeah. So, allowable bearing capacity is 165. Yeah. Now, for the given water table level, the provisional value should be multiplied by the factor C sub W, equation 8.0. Now they are saying to you that you need to apply correction for the allowable load. all right? Because there is a presence of water table. So then you apply that C sub W, and you put in your D sub W and this and your B's, all right? Okay, and you get your C sub W. You multiply the C sub W to the 165.89. Now your bearing capacity now, allowable bearing capacity is 150 kilonewton per meter squared, which is kilopascal. All right, kilopascal. Then beyond that is all the other methods, Mayor method and this Berlin and Burbridge. You're going to read up about that. I'm going to assume you know about that. I'm not going to talk too much about that anymore, because the important thing is to do only this one up here, and then the rest I think is pretty straightforward. Okay, any questions on that? No, right? Okay. Now the other penetrometer that we use for sand, the other one that we use is CPT, all right, cone penetration, cone penetrometer. Okay, so if you remember, I'm on page 16 now, unless you have any questions. All right, I have 54 people, 2 are now have gone. No, sorry, I have 1 gone now. Probably internet connectivity. I don't know. Anyway, CPT. All right, page 16. And if you need to read up, it's on page 226 to 332 on Craig. It uses the dash cone. This is what we did in site investigation. Then the tip resistance generally measured in bar, 100 kilopascal. I'm just reviewing some of these things that we did in site investigation when cone shape penetrometer is advanced in the soil, right? Then you have Mayhoff here. Okay, beyond that is probably some new stuff. So I'll just remind ourselves. I don't have those. Well, excuse me a minute. I have them somewhere. Okay. Right. Remember this when I'm I should remember about this when I was talking about SPT. I forgot that I actually have it in here. I brought that move. Anyway, here's my CPT, right? And as opposed to the SPT, which is a dash cone, sorry, not dash cone, the split spoon sampler, I'm not banging it in. And this one is more fragile, right? It's also more slender. The split spoon sampler is, you can split it open and it is hardier, right? It is designed as such. Here you have actually a cone. So you are actually pushing it in, all right? You're pushing it in. So the resistance from the soil is from the, at the tip, right? At the tip here, there is a resistance. Every time you push, you try to push your finger, say, into a bowl of rice, right? Not a bowl of rice, into a rice that is not boiled, you will find there is a resistance at the tip. And then around it, right? Around it, you will also have the surface of the penetrometer, right? Being in interaction with the material around it. So you have surface friction, right? Surface friction. Okay. So the resistance comes from the tip and from the surface resistance, the friction around the sleeve, right? So they call it the sleeve resistance. But that's just what we did in the site investigation. Then we said to ourselves the total resistance is from the tip and also from the friction. Okay. Now there is a relationship right, between this cone penetrometer, the resistance at the tip, the cone penetration, right, Q sub C, and the SPT. So if you do your SPT, but you didn't do your CPT, you can find what they are with respect to the depth, right? If you use those SPT values. That's like saying to you, you know, a few minutes ago, I did all this SPT with you at each depth. So I didn't do any CPT. And if I want to know the CPT Q sub C, I just take those values and I multiply by 4 and I get my Q sub C with that. Okay? Am I losing you or are you okay? Just say yes or no. Right? Q sub C is equal to 4 sub n. So I have SPT values with that. So I can now have my Q sub C with that. And the Q sub C is just the cone penetration. Okay. Then I also know that this Q sub C, all right, is related to the modulus of elasticity, Young's modulus of elasticity. All right. If I multiply by 2, is equal to Young's modulus of elasticity. Now, the Young's modulus of elasticity gives us an idea that this sand, all right, is going to behave elastically, right? Because Young modulus is to do with linearity, right? An idea of for every strain is somewhat related to some idea of stress being related to some strain. Okay? Now, this guy, Schmertman, all right, he did this analysis on settlement. And he says that if I can find this relationship between this cone penetration and the Young's modulus, then, you know, I can find the settlement. Because like I said a few minutes ago, modulus of elasticity E, right, is equal to stress over strain, right? So now stress, if I know what the stress is, then I can find the strain. If I know what E is, I also can find the strain, all right? So he says that, and then he, of course, you know, unlike, say, steel, which is, you know, has definite stress and strain point of failures and transition, soil, by now, you probably realize, doesn't quite behave perfectly elastic, all right? Nor does it behave perfectly plastic. So it is a combination of plastic and elastic. So we call that pseudo elastoplastic. Right? I think some of this definition were mentioned to you in soil mechanics too, if you can still remember. Otherwise, it's okay. All right. But which is why I'm going on to the next statement, which says settlement, all right, because the modulus of elasticity is a function of some Q sub C, the cone penetration, all right. Then I get the settlement according to Schmertman is going to be partially empirical. Okay. So that's why in the equation that follows, you will see some coefficient that are, you know, C sub 1, C sub 2, where does this coefficient all come from? But anyway, that's what is meant by that partial empirical method. By right, you shouldn't have this partial empirical method, right? Guys, am I losing you? Boaz says no. Emmy says no. Okay. So just to remind you, what I'm trying to say is that when you did your, I don't know what you call it in your class, that's strength of material or elasticity class, right? Okay. You have stress and strain, right? And then you're given a nice formula. Then you stick in numbers or whatever in that formula. All right. And then you get the stress or the strain. All right. And you get your settlement. All right. So strain equals to stress over modulus of elasticity, say, right? Or something like that. Okay. All right. So very nice, very straightforward. Here in the equation you see here, when it has been derived for you, all right, it is not so straightforward as that. It has C1, C sub 2 multiplied by delta B, and then the thickness of the material itself and some factors. Okay, some factors here. So it is not, you know, for a person who sees it the first time, you can't really say to yourself, how on earth is that related to stress and strain and modulus of elasticity? All right. So that's what I'm trying to say in terms of partial and partial empirical method. Okay. So anyway, I'm trying to explain to you soon. All right. All this what is components of the formula are in that equation. So you have C1 is a correction factor for footing depth. See, now you have a correction factor for footing depth. So what Schmertmann is trying to say to you, where the depth of the footing is, you need to do some correction. Why should I do correction? It has something to do with that. You know, a few minutes ago, we have that correction for the overburden pressure. And prior to that, we had this thing in the head, how stress history has an influence on settlement. Well, it's the same idea here. If you have higher footing nearer the surface and lower footing further away from the surface, then the soil is going to be compressed differently. Same idea. So that's why it says you have to apply some correction. All right, and you see that P prime naught and delta P. P prime naught is something to do with the overburden pressure. Okay, so delta P is P minus P prime naught. P is the foundation pressure, what you give. All right, and P prime naught is just the overburden pressure. Okay, if I go over the next page. Effective overburden pressure at foundation level. Now it's just the symbol is different. A few minutes ago when I was looking at rate, we were calculating that, all right, and it's the sigma prime V. Now is P prime naught, all right? So C sub 2 is a creep factor. Now this creep factor has a T in it. Creep is related to time, okay? Related to time. Now, if you recall, I said something about creep being, you know, if I have this wristwatch and all I did was just put some load towards it, right? Over time, say, I don't know, maybe 100 years, okay? Over time, this wrist, right? Assuming that it doesn't corrode or anything, right? Doesn't have any corrosion or anything like that. Over time, you will see that this wrist watch, the wrist of this watch, it will be elongated. All right, it will be elongated. So we call that creep. All right, the response of this material with a consistent load, right, consistent constant load with time, it just gives. All right, I don't know how to explain this anymore than that. All right, so that's why you see in that equation there is a time factor T there, right? So it's a creep factor. Then T time in years at which a settlement is required, okay? I sub Z is the strain influence factor, right? I sub Z is the strain influence factor. Now the modulus of elasticity is E is equal to 2.5 Q sub C for square footing, and E is equal to 3.5 Q sub C for a straight footing. The square footing is axial symmetry because it's symmetrical about, you know, square is the same on both sides. So it's axially symmetrical, right? On any axis is the same. When I say any axis, it's any axis from the center. But for a strict footing, you only have the breadth T and then all the way to China, right? Or to, I don't know, the North Pole. That the strain in that direction, you don't count for it. All right, it's Yeah, so any strain is going to occur in this direction only. So it's a plane strain problem. And plane strain problem, as I mentioned to you, is the same with retaining wall. All right. What else do you have? Embankment, which is, in that direction, you don't bother much with the strain. And Q sub C is the cone penetration resistant or cone resistant. Now, look at this picture here, the stress with the depth. I'm going to put my CPT, I'm going to penetrate my CPT into the ground. All right. So I have my CPT reaching a maximum value and then it peters out. In other words, you find that beyond 2B, the stress, all right, beyond 2B, the stress for the square footing is almost zero. Okay, almost zero. And then for the strip footing, it's about 4B, 4 times the breadth. It reaches some maximum value as I penetrate the penetrometer, and then it starts decreasing, and then at 4B is almost zero. Okay, and this is going to repeat for different footing size. Right? I have different footing size, right? So this is why on page 18, all right, Schmertman introduced to you this IZP. Instead of drawing, for every footing size, this stress diagram, and finding out where is the maximum, and then where it actually becomes zero, almost zero. Well, we know it becomes zero at this point at 4B and 2B, right? It's just the maximum value we don't know. So he says, well, why don't I make a dimension, all right, dimensionless, then multiply by whatever footing size. So this is why this is called IZ, the strain influence factor. And this is now Z over B. Okay, Z over B, and the strain influence factor reaches a peak value. All right, for L over B equals to 1. All right, it reaches a peak value at 0.5. All right, because the vertical axis now is Z over B. And then for the strip footing, which is defined by L over B, more than 10, equal to or more than 10 at 4. The value now is 4, because now the vertical axis is Z over B. Now, the peak influence factor, right, the peak strain influence factor is given by this formula, 0.5 plus 0.1 delta P over sigma primary P to the power of 0.5. Okay, so again down there it says IZP occurs at B over 2 for square footing, and then IZP occurs at B for L over B greater than 10. Right? Now, then all the other symbols, P is the load that you give. All right, here's the P, the load you give. This is P prime naught, which is the effective overburden pressure at IZB, sigma V prime P is the effective overburden pressure at IZ or IZP. P prime naught is at this point here, okay? The overburden pressure of the soil at the depth of the footing. Sigma V prime P is the effective overburden pressure at when the strain influence factor is at the peak value. Now, I'm going to give you a homework from Craig's book, but I want you to draw them like I draw them. You do not use Craig. I'm telling you now. If you do, and if I collect that homework, you get 0. Are you awake? And did you hear me? Hello, yes or no? Yes? Shasha says yes, Amy says yes, Paddy says yes, hear you, yes. You know why? Because I don't want you to draw like him. All right? Because I'm going to show you an example. Okay? And you're going to draw it yourself, the IZP. Okay, this IZP, you're going to draw it yourself. All right, like I showed it to you. And you're going to find the value according to this formula. Why am I doing this? Because some years I give question without the IZP in it. And then students come back to me and say, where is the IZP? Because when we did the homework, we did the IZP is given. I said, that's because it's given. If I don't give it to you, how do you do it? You don't know. Because I always have students who memorize. So I'm helping you out when I say it. So again, do you understand what I'm saying? Yes or no? Draw it, calculate it yourself. All right? Okay. Next week, you forget what I say. So, you look at this example then, overlay. All right? Okay. Hakimi, where are you? Say hello to me. So, we need break 10 minutes. Before that, firstly, before we have a break, Hakimi need to say hello to me. Is he around today or not? I think he has left the meeting. Betul tak, Fazli? Dia tak ada dalam ni, ada kelas motor. Hakim still like driving class, Hakim. Okay. All right. What driving class is that, Arman? Motor class. Learning how to drive a motorbike. Yes, okay. Why does he choose Tuesday? Very unlike him. Firstly, why? IDK, sir. What does IDK? Maybe that's the only slot left to learn. Ya Allah. So he's going to do it every Tuesday like that? And he says, I don't know. IDK is I don't know. Oh, okay. All right, Fazli, 10 minutes break. Shall we take 10 minutes break or 5 minutes break? 5 minutes break, Fazli. I just want to finish. Well, maybe, yeah, 10 minutes should be okay. Good. Try to finish as much as possible. Eh? Okay, 10 minutes, okay. All right. No, Iza Sahira. Okay, Iza, I remember. You know, all these names, right? After a while, it just remain named, you know? Like after after the 9 week or something, it just remain name. I can't even see a face anymore. Unless I see the photographs. You know what I'm trying to say? We are having a break now, right? 4:15, 4:25, we should start. Boleh minum air? Boleh lah, sir. Ni. Fazli, you nak minum air bukan you cakap pun. Saya yang minum air. Eddie is in a good mood, always laughing. Ha ha ha. Now, I sent a few articles to Shakila. Did she viral it to you? Do you have time to read those articles? You know, it doesn't matter whether if you don't read it. You know, I was just wondering if you read it and perhaps it helps you to understand the reality around what is happening to you. Anyone? Or Shakila didn't distribute it? Amy says no. No meaning Shakila didn't distribute it? I requested her to viral it. Or maybe I missed it. Okay. I'm sure Shakila's distributed. There's been like, I think, 3 articles I think I sent, but the one about the Sabah on the tree, well, forget it, you know. That one is just like, some people have it hard. But the other one was just about, they are discussing about all these online methods and all of that, right? In some ways, it is an admission that online preparation was not there. And the other one I just sent it is the reason why I think you probably be coming back for your final exams soon, right? Which I sent it to her today. Okay. Just Amy only is responding. Anyone else responding to that? Arman, do you see it? Because I think in your WhatsApp group, maybe you have so many other things, people talking about so many other different things. Sorry, but then I distributed 2 major articles. One was about, 3 articles. One was to do with a Sabahan girl who had to climb a tree to do her online exam. Shakila did not forward any article, sir. Ya Allah. Betul ke, Liana? That's bad. Maybe she's like, betul. Maybe she didn't have the internet or something like that. So who can I send it to? But we know about the Sabahan girl. How did you know about the Sabahan girl? If she didn't forward the article? The video is viral. Okay, fine. The video I know. Alright, but there were 2 other things. Nur Izzah Shaira, Facebook. Okay, fine. It was viral, fine. But the other 2 were about, one was about the online learning. I can't remember the title, okay, about online learning. And the other one was today about I sent it to her about why the professional, I mentioned this to you, why the professional degree would require that you come back for your final exam. Okay. So I sent it to her to viral, but she didn't viral it to you, huh? So I can give it to, maybe to share. I have what's the name? Shasha's number. I probably give it to Shasha, and then she can perhaps viral to you guys if she has the your WhatsApp group number. Boleh Shasha? Ni apa yang tengok sinema dah boleh ni, takkan tak boleh balik universiti? Tak boleh balik sampai December 31st. Dia orang penakut. Okay, Shasha says, okay sir, I'll do that sometime today, right? I just don't know why Shakila didn't send it to you. Where is she? Because I think she may have problems. She may have problem with her internet. You see, 1 meter apart dekat mana nak buat Izzah? Exam you will have to probably come back lah. I'll send you the 2 articles today. Reviral balik. See, like I said to you, you can come back only next year. Izzah saya tak nampak masa depan macam ni, Izzah. Macam ni lah, Izzah. Sampai tahun depan you baru boleh balik. And then you have your last semester here. Unless from the SMP they said online panel. Dah confirm dah, Liana? The date semua. Ha? From the SMP, they said online final. Entahlah, saya tak tahulah. Ini yang dulu punya kot. Ini tak, the university will have online final, but for programs like medicine dengan engineering, there's no way. Unless of course they don't care lah. Masa depan dah settle down. Jumpa classmate kekok, kena buat ice breaking balik. Belum keluar lagi Fazli. Tak tahulah dia orang ni bila nak keluar. Dia dah minggu 11 lah. As far as I know, belum keluar lagi. But I haven't been back to the faculty anyway. Alright. Because the BEM, right, Board of Engineers is saying that you have to ensure the integrity. As I've said to you, that the faculty may, however, have already put forward the idea, right, that you guys have to come back for your final exam. But the university may overturn it, right? So, integrity macam mana dengan COVID ni? Itulah dia, Iskandar. You sampai bila pun orang akan apa, shock, suspicious of your grade. Kena dapat A pun, orang tengok A tu pun tak ya tak tidak A ni. Macam mana? That's why, like I said, in the universities, some of the universities in America, okay, they just can't be bothered with giving you grades. Jadi cakap dengan Iskandar, right? They can't be bothered about grade. Itulah suit dengan keadaan. Tak payah bagi grade A, B, C, D dah. Lepas tu, terus masuk dalam CGPA. Right? Itu memanglah, Izzah. Then your A tu orang putih kata ya macam toilet roll. That's the value. You see, like Britain, A level, O level pun tak ada, MCE pun tak ada. Mana apa MCE tak ada, HSC pun tak ada. Malaysia tak buat juga lagi. Aduh, sekarang nak emergency case macam mana lagi? Pregnant woman dia lah emergency. You nak emergency apa? Sebab tu saya pun tak tahu nak cakap apa dah. Kan? Tapi kalau you know, if we don't have that final example, as far as I'm concerned, you know, as far as I'm concerned, it doesn't affect me. It affects you. You see? And if I were you, I would ask for that final exam. Kan? So that people don't have this thing in their head. The first article tu, you know, if you were to have macam dekat UTM, what UTM has is a very complicated online system to assess exam. That will be very expensive. I don't think UPM is ready for that. You see, I don't know what they were ready for. Because they didn't think this online was going to happen like suddenly, you know. Right? A proper online learning would have been rather different, right? I mean, in terms of what we are doing now. Well, what I'm doing now is that just transferring myself to just Google Meet. Lectures are all basically the same, you know. I can't get you to be active in a better way, right? There are better ways of doing this, but I don't think we are ready for that. Yeah. So I don't know. Anyway, you know, if my feeling is that if you don't have that final exam on campus, all right, given that your second test is already suspect, all right, then you will have this issue, people wondering, okay, forever, right? So then you have to like prove your worth in through other ways, okay? If they don't anyway, right? They might not say to you, they might take you in, and then they just like wonder in their head anyway, right? It's like the PNB, it is, you know, that PNB CEO, right? What's his name, Jalil Rashid, if you follow the news now, and then people say that, you know, he's been fired out of his job because he didn't, you know, he didn't put the university he went to correctly. Well, he went to the London School of Economics. Most people would know that LSE is part of the University of London, so it doesn't matter whether you do or you don't put, right? You know, correctly or incorrectly, right? You get your degree from the University of London, but you actually go and study at LSE, which is the London School of Economics. So most people know that anyway, right? But if you want to make a big issue out of it, you can always make a big issue out of it, right? You didn't put it correctly, you know, in your CV, you know. So, you know, it's something like that that will be in people's head. So they can always make an issue out of it, right? Or they don't have to, right? Okay. Anyway, are we done with the, yeah, with 4:30, Fazli is back, I think. All right. Akmal Arman say politics. You see, what I'm trying to get at is, Arman, it could be politics and they could, yeah, make an issue out of nothing. You see? So for you, what I'm getting at is that it be doubtful. All right. So sometime in your future, somebody can do the same to you. All right. So from my standpoint, to play safe, then it's better you come and do the final exam here. Then at least you can say, hey, I went back on campus to sit for my final exam. So there is no issue of integrity. If you want to question about integrity, then you should question, you know, face-to-face learning for donkey years, like even your own degree. You see what I'm trying to say? You understand my logic? I feel like I'm talking to myself sometimes. All right, Amy says I got your point. All right, I have an example. And then after the example, maybe I'll do page 21 and 22 and 23, and then we call it a day lah. Yeah? And we talk about allowable settlement. If I want to, if I'm not tired. Okay. Now, I'm on that example now. You're on that example, right? Okay. So I have a load of 1 meganewton. My dead load, my life load, all there, 1 meganewton. And then I'm saying to myself that I'm going to use a square footing, 2 by 2 meters. All right. And that footing, I'm going to found it at a depth of 1 meter from the surface. And obviously this is in sense since we are talking about the CPT. And I need only to know gamma is equal to 20 kilonewton per meter cube. In this case, the water table is not given to me. All right. So I'm assuming that the water table is very far below the depth of the footing. All right. So I will draw that see here, I will draw here the footing 1 meter depth, and then I have at least this 2B, which is the 4 meters depth, which is the, if I go back here, all right, if I go back to this, okay, here I said that between B and D plus B, this is what Craig said, okay, here I'm just doing my, that's to do with the general shear failure. Here, I'm just looking at the, how far deep am I going to do this SPT and CPT testing, if need be. All right. So because I know that, this, all right, because I know this here, or because I know this is easier for me to show it here, because I know that this stresses here, all right, for a square footing, it is at least 2B where it becomes 0, and for a straight footing 4B. So to cover for my conservatism, all right, I would have normally my footing depth for any site investigation using SPT and CPT at least up to 2B, all right, 4 meters, all right, if you're wondering why there is this 2B 4 meters. Now, I did my CPT, and this is the result, okay, all right, it has some depth, some Q sub C values, okay, and then this is being recorded at all the depth, all right. Now, at each of those depth, I can then multiply by 4 and get my SPT as well, right? If I want to. Now, I'm applying my load and I'm divide by the area. Therefore, my stress start being applied 1 meter below the surface of the footing. Yes, 1 meter below the footing. So, this is my stress influence chart. It starts from 1 meter below the depth of the footing. I'm going to draw that. You have to draw this. Okay, you have to draw that. If whatever homework I give you on this, you must draw it. All right. And then when you draw it, you're going to find the IZP. The IZP, I've already given you the formula. Here's the formula, IZP. And I've defined to you all those delta P and sigma P prime P. All right. You will do the same. Whatever homework I give. All right. So you find the IZP, applying this formula, and in this case, I get it to be 0.74. All right. So I'm not going to be bothered about the delta P and sigma VP because I already explained to you. So I get 1.74. Then P is given as 250 kilopascal. Sigma V prime P is the overburden pressure when IZ equals to IZP. So IZP occurs 2 meters from the top of the surface of the soil. Yeah, because the 1 meter is when you begin to stress the soil, and therefore you get the strain and stress influence factor. Then IZP, if you look at this thing here, right, IZP occurs at B over 2 for the square footing. So since the footing is 2 meters, so I get it to be 1 meter. All right. Okay, I'm taking time about this. I may get to be not bothered about the next few pages after this. I may be tired, in other words. So I, in applying the IZP, IP prime naught is 20 times 1. That's just sigma VP, right? Sigma, not sigma VP, sigma overburden stress. Since the footing is 1 meter depth, the unit weight is 20. So gamma multiplied by Z. Delta P is equal to 250 minus 20. 1 meganewton divided by 4 is equal to 50 kilopascal. All right. You may not know, see this, P 250 kilopascal. I don't know how to see. P equal to 250 kilopascal, 1 meganewton divided by 4, the area, the stress is 250. So delta P is 250 minus 20, 230. So this is how I get my IZP. Okay? All right. Ayn, okay, Ayn? If Ayn is okay, everybody else will be okay. Yes, Ayn? I have 53 people. 5 people has gone. right? Well, too bad for them anyway. So then I just will look at this picture here. All right, I'm going to divide it into 4 layers. 1:2, 2:3, 3:4, 4:5. 1:2 is from 1 meter to 2 meter deep, 2 meter to 3 meter deep, 3 meter to 4 meter deep, 4 to 5 meter deep. But this 1 to 2 is from the top. All right, from the top here. Just be careful about that. Okay. Okay. I may be wrong in that layer. It is not from the, well, you look at the I sub z, all right? I sub z is 0.37, so I'm not wrong. And I'm saying that 1 to 2 is between here, 1, and then this is 1 meter deep, right? This is, this peak here is 1 meter deep, so from the surface is 2 meters deep, yeah? Okay, so 1 and 2, all right, in between 1 and 2, 4 layers. So I have in the middle of that 1:2, all right, is 0.37. We always try to find it in the between a layer. First, we divide it into the same equal layers, then we take it in the middle of that layer, because the middle of that layer is the average of the top layer and the bottom layer of that layer. Am I missing? Here's the thing. Yeah. So here's, yeah, 1 meter, 2 meter. I'm taking in the middle, average of top and bottom. Okay. Ain nampak kan ni Ain? It's okay Ain if I use you as orang kata apa tu, as a guiding pole, ya. As a benchmark. Ain tidur ke? Okay. Okay tak ni? Nampak tak ni? Okay, right? Anyone else not clear? Okay, right? So when I'm getting at this 0.37, I'm getting it somewhere here. Kan? I'm getting it right somewhere here, right? Halfway between between 0 and 0.74. Okay? All right. So, okay, then 2.3, 0.56, 0.27, and 0.19. All right? Then I'm just looking at that influence factor and I'm getting it off that chart, or not the chart, yeah, sort of a chart of this thing I'm drawing. Okay? And it reaches a peak and it has a minimum value and 0. Okay. So then I get the same Q sub C from where it is on the Q sub C chart with that. Also in the middle. Okay, also in the middle of that layer. All right. Now, I may have, see here, I draw a Q sub C. Yeah. Okay, guys, I draw the Q sub C with that. Q sub C versus that. Sub C versus. Remember this thing here that I drew is just as I'm pushing, it is resisting. The soil is resisting. So it's giving me a resisting value. So that's the Q sub C. And then I'm pushing it again. This is what this curve is telling me. Yeah. So see, in this case, it is smaller here and then it is higher here, right? At 1 meter and 2 meter deep. So I'm saying to myself, maybe it is average halfway through like that. So I'm going to put like maybe, and then here, right? Do the same for all of that, right? Okay. So average of the value, and then this will make it constant for that layer, for the Q sub C. Okay, guys. Now, this on this page. Yeah, example 8.6, page 330 and 331. All right, can you like look at it now here? See what I'm doing here? And it's being repeated here. Okay. Come on, guys. Are you on page 331? Okay. Ni Amy je yang cakap okay, lain orang tak cakap pun. Yana cakap juga, yes, Fazli okay. Izzah cakap juga. But all the other people are quiet. Same people only saying the same thing. Shah Irman will say, and this not today I see Shah Irman. Okay, guys, fine. Right. Okay. So, now, you can just get IZ over E, right? And then you can calculate all of that. And E here, I'm using 2.5 QC. If you use Craig, he uses 2 QC, all right? Okay, he uses 2 QC and not 2.5. Right? You can use either one, but I prefer you use 2.5. Okay. All right. That's because that's what Schmertman says. All right. Now, and then you just stick it into the equation, yeah? You just stick it into the equation and you get the settlement. I don't think there is anything there that is difficult to follow. Now, if you want to do it now, in other words, the settlement now that you want to find out, then obviously there is no creep factor. Remember I said to you that creep is a function of time. Okay, so if it is a function of time, then if you want the settlement now, you put the load now and you want the settlement value, then obviously you don't account for the creep. But if I were to say find also the settlement in 5 years' time, then there is that influence of creep, right? So now T become 5 years. So now this one here, the settlement without the creep factor in it, all right? That's the settlement now. And then if you include the creep factor, then T will be 5, right? Then you will put the value of C sub 2, C subscript 2, it wouldn't become 1 anymore, right? It wouldn't become 1 anymore. If it is now, there is no correction, so it is 1. If it is with time, right? You have creep factor, then it wouldn't become 1. It would become some other number less than 1. All right? Now the settlement is increased or decreasing with respect to that creep factor. All right. Now C sub 1 is just a correction factor due to the overburden stress, right? So the overburden stress, that's the P prime naught. I already explained delta P is the change in the stresses that are being applied. So there you are, that's the correction. So you get that. At the bottom there it says do example 8.6, page 330 for your homework. Well, I'm not going to ask you to do that. You can go through example on the page 330. Now, again, in this one here on page 330, if you're using the Schmertman method, all right, you have the Q sub C with depth, and then this was already drawn. The IZ is drawn. Draw it yourself, determine the IZP. This is not what I want, all right? This is what Craig wants you to do. That's not what I issue. Got it, guys? I'm waiting for an answer. Okay. Got it. All right. If you do it, if you just do this chart and then write according to Craig, this IZP according to Craig, because Craig tells you, all right, that the value is 0.6. You look here on this page. This page is page 329. He says to you the value of IZP. You don't need to apply any formula. It is 0.6. Did I tell you that? It can be any number, yes or no? Yes, it can be any number, a function of what you apply. Yeah. So if you start doing this, all right, in the test, in any way I ask you to do it, you get 0 mark because you don't listen to what I said to you. Okay, again, yes or no? Yes or no? This is the third time I'm reminding you. I is saying yes. See, if I say yes, everybody will know. Okay. All right. Because every year I get funny people in my class. I don't know why. So now you go and do this for your own learning. Yeah, at the bottom there, do example 8.6, page 330, because I'm not explaining all the other methods in there. You are going to learn it. All right. The time now is 4:45. I can finish settlement and go into allowable settlement today, or shall I do it the next time I see you? It'll take about 15 minutes to finish the settlement part, and allowable settlement I'll just take 5 minutes or 15 minutes. Next time I see you for pile. Shall we finish it now? So many. Ya, Fazli, bearing capacity pun banyak, settlement pun banyak. I remember Izzah saying to me, itu je. Belajar bearing capacity settlement je. Ya. Tapi sekarang tahu banyak. Mana Izzah? Izzah dah senyap tu dah. Ya, ada lagi. Ya, itulah. Kali tu hari cakap itu je nak belajar, bearing capacity settlement, shallow footing, pile apa, deep footing. Ya, Izzah cakap, saya ingat lagi, saya pun senyum waktu tu. Baru tahu. Now, do you want me to continue now or do you want me to continue next time? I have to give you homework. Actually, I told Shakila I was going to give homework today. But then I thought, no point in me rushing if you don't follow me. Guys, shall I do it next week or continue today? This last part of the settlement, which is the using the plate bearing. Then allowable settlement is the end. Aida ni dia senyum je. Janganlah homework hari ni, sir. Homework next week. But I should have given it to you today. But do you want me to apa? To sedih? Oh, ya ke? Lupa nak tengok macam ni. Tengok macam ni dia nampak senyum lah. Kalau continue today, nanti saya bagi homework hari ni ke? Tak ada yang ini. You tengoklah the notes. I said, you see, granular soil, display bearing loading je. Lepas tu allowable settlement. Kan, allowable settlement tu I thought next week. In fact, I told you earlier, I'm going to finish up to page 23 tadi. Alah, kalau macam ni, I'll tell you next week lah. Yeah, we start next week lah, okay? But remember, remember, if we don't finish, we have to finish. So if it takes you sampai pukul 12 malam belajar, nasib lah. Okay? Ni Fazli dah cakap, dah pening kepala dah. Tahu belajar dua benda je hari ni. Aida, ni kenapa nama Wu ni? Now I finish for today, right? Okay, done. Dia Korean, betul ke dia Korean? Rohimatu Toyiba. Nama aku main lagi, Toyiba tu. Nak pronounce aku ni. Dia artis. Oh Allah. Macam-macam budak-budak ni. Muslim Korean. Korean usually nama Kim. Nah. Pening lagi foundation. Allah. Macam ni je pening. Hidup lagi pening. Taibah. Kim Dawu. Merah Kitty. Well, at least you are happy. You see, I was, I didn't realize how difficult it is until I went to the, I haven't been to my mechanic for a long time. That's because, of the MCO